Today's lesson is about scientific notation, and we use scientific notation whenever we're dealing with very large or very small numbers. So an example of a very small number would be something like the following, or a very large number would be something like this. Okay, and as we can see, these types of numbers are kind of time consuming to write. It's easy to lose track of how many zeros are in them, and so we use a kind of a shorthand notation, which is called scientific notation, in order to better represent those numbers. Numbers expressed in scientific notation are written as the product of a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10. The decimal point will always be to the right of the leftmost digit. So let's look at a few examples. If we were to write the number 92,000 in scientific notation, the first thing that we would do is move our decimal point to the right of the leftmost digit. So in our case, 9 is the leftmost digit, so our decimal point will go to the right of the 9. Then we multiply that by a power of 10. And the way we figure out what that power of 10 should be is we simply count how many places we had to move the decimal. Our decimal started out in the place that I just marked here. So when we moved it, we actually moved it 1, 2, 3, 4 places. So this would be 9.2 times 10 to the 4th. We really don't need those extra digits, those extra zeros in this particular example. All right, let's do another one for a large number. If we had 834,800,000, okay, the first thing that we would do is move our decimal point to the right of the leftmost digit. So let's rewrite the number as 8.348, and we don't need all those extra zeros. And it would be times 10 to a power, and the way we figure out what that power is we simply count from where the decimal was to where we put it. So 1, 2, 3, 4, 5, 6, 7, 8. So this would be 8.348 times 10 to the 8th. Okay, and I know that you've done some of this with Mr. Meyer more towards the beginning of the year, so hopefully some of this looks a little bit familiar. If we look at, taking an example with a smaller number, and let's do 0.00002,605. Okay, I'm going to start off the same way. We're going to go ahead and put the decimal to the left, to the right of the leftmost non-zero digit. So while 0 is really the leftmost digit, we don't count that. We're looking for the first non-zero digit that we get to. So 2 is the first non-zero digit. And we're going to put our decimal point to the right of that 2. So we'll rewrite it once again, and we'll say 2.605, and we're going to count it once again how many times we moved the decimal, how many places that we moved the decimal. So in this case, we moved the decimal 1, 2, 3, 4, 5 places. Okay, so we're going to put a 5 up here. But what we should notice is that in our first two examples up top, those were both large numbers. They were numbers that were larger than 1, and therefore they had a positive exponent. When we look at the bottom example, one we're working on right now, this is a number that's smaller than 1. So the exponent is not going to be positive, the exponent will be negative. So it's not a positive 5, but it's a negative 5. Okay, let's do one more example with a small number. So the number that we're working with right now will be 0.000003576. Okay, so it's in standard form right now. Okay, the way that you're used to seeing the numbers is called standard form. We're going to take it from standard form and put it into scientific notation. So once again, we look for the first non-zero digit, that's the 3. So our decimal point is going to go right after that first non-zero digit, and we'll rewrite it then as 3.576. Okay? Once again, times 10 to a particular power. How do we know what power? Well, we're going to count again. We're going to count how many places we move to this decimal to get it from here all the way over here. So 1, 2, 3, 4, 5, 6. We moved it 6 places. So we put a 6 up here as our exponent. And once again, we have to realize this is not a large number. This is a very small number. This is a number less than 1. Numbers less than 1 in scientific notation will have a negative exponent. So it would be times 10 to the negative 6th. Okay, so from here, what we have to do is we have to also learn how to go from scientific notation into standard form. So let's take a look at an example of that. In scientific notation, if we have 3.253 times 10 to the 6th, okay, and we want to change that into standard form, we go ahead and we're going to write those digits, the 3253 that we see up there, and then we're going to move that decimal 6 places. Because the exponent is positive, that's a positive 6 and not a negative 6, we're going to move the decimal to the right. So let's go ahead and do that. If we're starting out with our decimal right here, okay, and we want to move it 6 to the right, we go 1, 2, 3, 4, 5, 6. We're going to fill in the bounces with zeros. Okay, and there we go. Okay, be very careful that when you do this, one thing to be aware of, when you move the decimal 6 places, make sure you're starting from where the decimal point is. Don't start from the end of the number and then count 6 over. You start from where the decimal is and count 6. Okay, so it's very important. You start here and go 1, 2, 3, 4, 5, 6. Don't start here at the end of the number. Start from where the decimal is currently. Okay, so I wrote that rule down that if the exponent is positive, move the decimal point that many places to the right. Okay, now let's look at one where we're going to go once again from scientific notation into standard form, but we're going to have a negative exponent. So if we have 8.3004, and it's times 10 to the negative 5th, okay, then I'm going to rewrite the number down here. Okay, those digits, and I'm going to move my decimal this time 5 places to the left because I have a negative exponent. So a negative exponent tells me that this decimal place is going to hop to the left 5 places. So here we go. I'm going to go 1, 2, 3, 4, 5, and put our decimal right there. Okay, then we're going to fill in our bounces with zeros. Okay, so here's our number in standard notation, 0.000083004. Okay, so let's write that rule down. If the exponent is negative, move the decimal point to the left. Okay, so last thing, your assignment for today, will be on page 319 of your textbook. And I'd like for you to do numbers 14 through 30. And we're going to do evens. Okay, and I would like you guys to, show all your work. Write down the problem that, and then write down your answer. And I should see, some work there. I should see you, moving the decimal place over and things like that. So that's it for today. And also, just so you guys know, your quizzes should be coming back to you from last week over mean, median, and mode. Some of you did not do as well as I had hoped, and probably not as well as you would have liked either. So those of you who would like to do a retake need to be prepared to do that tomorrow. I don't think the problem is that any of you don't know or are not capable of doing it, but I'm not sure that very many of you prepared as much as you should and knew the difference between the three different terms. So you need to make sure that you know that for tomorrow, and I'll spend a little bit of time tomorrow reviewing with you before you're given the opportunity to do a retake. So I will see you tomorrow.